Alright, Chapter 2, Angle Pulse Modulation. Navy Electricity Electronic Training Series, Module 12, Modulation. Chapter 2, Angle and Pulse Modulation. Learners object for the blind completion of the chapter to be able to describe the frequency shifting frequency shift keying method provided with the type of the modulation, describe the difference with the frequency modulation method, the frequency modulation of the modulating carrier. Describe the development of the phase modulation, the method of the phase modulating carrier. Describe the phase keying, phase shift keying, and in generation applications. Describe the development of the character of the pulse modulation. Describe the operation spark plug for the diatron modulator. Describe the character of the pulse stream that may be varied with the provided communication capability. Describe the pulse amplitude and modulation. Generation, pulse duration. Describe pulse duration, modulation, and generation. Describe pulse position modulation. Generation, pulse frequency modulation. Generation, pulse code modulation, and generation. Introduction. In this chapter, you've learned the modulation carrier frequency necessary to allow the last of the communication between 2 points of volume of the transmission crew with the need for a more reliable method of communication rails realized. In this chapter, we will study the angle modulation, pole of the modulation. The two types of the modulation have to develop and overcome one of the main disadvantages of amplitude modulation. Suspectably, noise interference with addition with a special application pulse type modulation for the ranging detection equipment will be discussed. Angle modulation. Angle modulation is the modulation which an angle of the sim wave carrier is varied by the modulating wave. Frequency modulation or phase frequency modulation and phase modulation are two types of the angle modulation. The frequency modulation modulating signal cause the carrier frequencies to vary with the variation of the control of the both frequency and amplitude of the modulating wave. In the phase modulating phase of the carrier, the control of the modulation waveform. Let's study each modulation method with the understanding of the similarity to difference of the frequency modulation system. A frequency modulation audio signal achieves the shift of the frequency of the oscillator at an audio rate. The simplest form of the sequencing form of this is saying the frequency shifting key. The frequency shifting key is somewhat similar to the continuous wave key in the AM transmission. The frequency shifting key with the figure 2-1 view A through D view A with the radio frequency of the carrier, which is the actual several thousands of the or million hertz of view B, the representative of the intelligence to be transmitted with the marks or space. The recall that every continuous wave transmission, this intelligence was applied with the radio frequency carrier by the interrupting signal shown view C with the amplitude of the radio frequency alternated between the maximum 0 volts. But by comparing views B and C, you can see that the mark space of the intelligence of the Morse code, the chapter of the character on the radio frequency with the spacing of the waveform of view D with the example of the same intelligence as it is applied with the frequency instead of the amplitude of the radio frequency. The symbol, the frequency shifting key of the same as Morse code character. Amplitude, radio frequency carrier, the continuous wave, each cycle will represent several thousands of the several million cycles. Common comparison of the on and off frequency shift key. Frequency shift keying of the radio frequency carrier, continuous wave, each cycle will represent the several thousand, several millions of the cycle. Alright, your time, 0 mark, space, mark, amplitude varying on and off modulating wave, Morse code character, N. 2M comparison of the on and off frequency shift keying, amplitude varying on and off modulating Morse code character, N. 2-1C comparison on and off frequency shift keying transmitted on and off continuous wave signal. Amplitude transmitted on and off continuous wave signal. Amplitude, the D transmitted frequency shift key signal, comparison on frequency shift keying, transmitted frequency shift keying keyed signal or FSK. And frequency shift keying, the output is abruptly charged between the two different frequencies by opening and closing the key, but this is shown in view D. The illustrated purpose of the space frequency in view D shown as the double the marking of the frequency. However, in practical difference, it is usually less than 1,000 hertz, even with the operating several megahertz. You should not limit the frequency shift key determined without the reference amplitude of the key signal of the frequency shift keying system. Frequency shift may be set with a plus of the minimum of 425 hertz. That from the allocated channel frequency, the total shift between the mark of the space would be 850 hertz. Either the mark of the space, either the higher of the two frequencies, the upper frequency of the transmitted signal, usually spaced interval with the lower frequency in the marking interval. Alright, comparing frequency shift keying with a continuous wave signal. The comparison with the on and off keyed for continuous wave, figure 2, view A, B, and C of frequency shift keying, figure 2-3. View A, B, and C signals show early with the principles for each of the frequency shift keying given us a basis with the frequency modulation can be discussed. Let's just use the views A, B, and C for the both figures to show the Morse code character F. For an example, the figure for the 2-2 and 2-3, a graphic drawn with the two type of the keying, the time and amplitude with the known with the dimensions of the A. But explain the frequency sheet if properly would they have added the third dimension of the frequency. Show the amplitude frequency change with the time, the three-dimensional representation on off the key frequency, continuous wave telephone graphic signal and amplitude and time. The response of the modulator to the signal in comparison to the AM and FM receiver respond to the AM signal, respond to the AM modulator to the signal. Our frequency assigned time respond for the discriminator to the signal. The comparison of the AM, the FM receiver respond for the AM signal, respond for the FM discriminator to the signal. Show the three-dimensional representation of keyed continuous wave frequency shift telegraphical signal amplitude frequency time. Comparison of the AM and FM receiver the respond for the AM signal, AM and FM signal respond for the AM demodulator signal. The frequency market signs bathe the time. This respond for the FM discriminator to the signal. For a continuous wave signal, since the continuous wave signal is essential for the constant and frequency, there is no variation along with the frequency active view A and figure 2C with the complete intelligence carry of the variation and amplitude of the signal receiver. The intelligence carrier by the signal of the receiver, the equipment that must be able to scan the signal along with the time and the amplitude of which carry the information was scanned along with the time and the amplitude of the axis shown the UB with the intelligence appears to be at large change that is large changes as in amplitude. The circuit where perfect and variation would be the zero amplitude with the sum of the maximum value with established with the transmit power distance and so forth, depending on whether the key were open or closed. However, the interfering component of the energy cover of the atmospheric interfering stations and electrical machinery appear the additional variation along with the amplitude. The axis of these with the amplitude variation appropriate the key variation cover the key to intelligence signal was blocked out by the interference which had all heard about appeared on AM radios during the storm, during storms or where near operating machinery. You see with the figure 2-2 represented with the same signal scan along the time of the frequency axis would be in an FM receiver. The variation signal amplified have no efficiency for the frequency. No intelligence can be received. Note that the noise and interference communication has also been suppressed so that they have little effect to receive the signal. The intelligent variation was impressed with the change of the frequency accuracy of the receiver. The equipment that was designed to respond with the type of signal. The effect with the noise interference would be practically eliminated. Frequency shift key after the circuit is filled with these conditions. Your frequency shift keying signal. The frequency shift keying of the radio frequency signal is shifted in frequency, not amplitude, because of the key open and the key closed condition. The signal amplitude remains essential constant with the view A with figure 2-3 with the represented with the letter F with the key, then the shifted of the frequency between the mark and the space. The normal frequency condition of the key is open is a space. The recall that may either lower or higher frequency when the key is closed. The frequency instantly and change the mark with the value of the remainder of the constant during the marking interval. Will open the key again. Return to the frequency space frequency midway between the mark and the space frequency is slammed with the channel frequency. Is shown in view A with the variation along with the amplitude axis caused by the same number of the interference modulation mentioned earlier. The right-hand portion of the view A with the illustrative the elimination of the noise by receiving the equipment. The view B clearly shows the scanning of the signal along the amplitude time of the axis is reproduced the no amplitude variation signal interference. However, the scanning accomplished above along the frequency of the time axis intelligent reproduction is shown the UC by the system. The intelligence can be recovered. Receiving the station original form will be nearly unaffected with the condition radio path other than fading. As a matter of fact, the frequency shifting resists the effect of the fading better than continuous wave. Alright, frequency shift keying. In the simplest form of the frequency shift keying of the transmitter can be accomplished with a shunting with a capacitor or inductor with a key, then steer with across an oscillator circuit by locking normal key with the transmitter with the operating only with the oscillator circuit key. You can change the oscillator frequency, the shifting of the frequency between the mark with the key closed and the space with the key open can determine the effect with the additional capacity, the inductancy of the oscillator, the frequency multiplication factor with the transmitter amplifier must be taken into consideration whenever determining the oscillator frequency shift. Thus, it is desired shift if the conventional 850 Hz for the transmission frequency and the frequency are 4 times the oscillator of the frequency be doubled in 2 stages. The effect with the additional capacity or inductancy on the oscillator must be limited to 212.5 Hertz as shown below. Total frequency 850 Hertz multiplication factor per stage is 2. The number of the amplifier stages total multiplication factor 2 times 2. And limiting value of the capacity inducted term of the frequency variation would be 4 over the square root of 850. 4 divided by 850 or 212.5 Hertz. Frequency shift gears are of course more to complicate with a simple illustration would seem with this show that the basic principle are the same. Still, the key does the chain with the oscillator frequency by a certain number of the cycle. The further the chain must be correlated with the multiplication factor of the transmitter to cause the desired shift between the mark and the space frequency. Method of the frequency shift key of the operator with either the two general principles of the key that may key with the output transmitter master oscillator modulating with the output with another oscillator frequency shift key. The action will result in the two frequencies that usually excite with the first amplifier stage of the transmitter system as illustrated in view A with the figure 2.4, view B illustrated with the second method of the frequency shift key operation. In this method, the transmitter master oscillator itself is shifted in frequency by the market space impulsation of the key oscillator unit. Figure 2.4H of the two methods of frequency shift keying with the frequency shift keying with the modulating master oscillator output the key input with the frequency shift keyer to the intermediate power amplifier transmitter. Also go to the X of the master oscillator. Master oscillator go back to the frequency shift key operator. And then the other route is then from intermediate power amplifier final power amplifier to the antenna. I guess. Your frequency shift keying the master oscillator key input with the frequency shift key to the master oscillator intermediate power amplifier final power amplifier antenna. Advantage of frequency shift keying over the AM. Frequency shift keying with the all signal channel with the radio telegraph system and the automatic pruning system. With the advantage of the frequency shift keying over the non-key continuous wave is that rejected unwanted signal noise that are weak of the desired signal. This is true with all the FM signals. Also, since the signal was also represented with the frequency she kept the frequency shift keying receiver automatic volume control method that may be used to minimize the effect of the signal fading caused by ionic variation. The amount of the inherent signal to the noise ratio improvement of the frequency shift keying over the AM approximately 3 to 4 decibels. Improvement is because of the signal improvement energy of the frequency shift keying is always present for the signal energy to present only 1/2 of the time of the AM system. Note for the continuous presence of both the frequency shift key and the AM, they eliminate with the frequency shift key the reception under the rapid fading of the high noise condition that commonly exhibit the high frequency region. Frequency shift keying show the market advantage over the AM. Overall improvement is sometimes expressed with the ratio of the transmitted power required to give equivalent transmission results over the two systems. Such as the ratio varies widely depending on the prevailing condition. Little fading of the ratio will not may be entirely resolved with the improvement of the signal noise ratio may be either under 5 decibels. However, under severe fading condition, large amount of the power often fail with a give good result of the AM transmission. At the same time, frequency shift keying may be satisfactory nominal power with the power ratio of frequency shift keying versus the AM would become an infinite within such cases. Another application for frequency shift keying is a low and very low frequencies below 300 kilohertz. At these frequencies, the key speeding are limited by a flywheel attached effect with extremely large capacity inductance antenna circuits. These circuits tend to oscillate their resonant frequency. The frequency shifting of the transmitter chain with the antenna resonance for the same keying impulse will be resolved with a much greater keying speed. As a result, use expensive channels is much more efficient. Frequency modulation. Frequency modulation, instantaneous frequency of the radio frequency wave is varied with the accordance with the modulation signal shown in view A of the figure 2.5 of the modulate method mentioned earlier with the amplitude with the kept constant with the result of the oscillation similar to the illustrated view B with the number of times per second the instantaneous frequency is varied with the average of the carrier frequency is controlled by the frequency of the modulation signal, the amount with which the frequency departs from the average control of the amplitude of the modulation signal, the variation over that with the frequency deviation frequency modulated wave. You can now establish two clear rule for the frequency elevation rate and amplitude frequency modulation. Amplitude time and the frequency effective frequency modulation on the radio frequency carrier. Amount of the frequency shift that is proportional to the amplitude of the modulating signal. This rule simply means that with a 10-volt signal caused with the frequency shift of the 10 kilohertz, then a 20-volt signal will cause the frequency shift of 40 kilohertz. The rate of the frequency shift is proportional to the frequency of the modulation signal. Second rule means that the carrier modulated 1 kilohertz tone, but the carrier is changing term frequency 100 times, 1,000 times per second. Figure 2.6 illustrates simple oscillator circuit with addition with the microphone in the shown with the oscillator tank circuit with although the condenser microphone capacity it was actual very low capacity of the microphone will be considered near the tuning circuit capacitor with the frequency of the oscillation of the circuit is covered the course determined by the inductor capacitor product of the elements of the circuit about the product with the inductance of the combined capacity of the capacitor in M, the modulator are primary with the frequency component. When the no sound wave strike with the modulator, the frequency of the radio frequency carrier frequency, any of the excitation of the modulator will alter the capacity. Therefore, the frequency of the oscillator circle with the figure 2.7 illustrates how the capacity of the microphone. M was microphone. Microphone during the excitation of view A with the auto frequency, but there was wave 3 level the intensity of the X and X shows X whisper Y normal voice Z and loud voice. In view B, the same condition with the intensity are repeated, but at the time of the frequency twice that of the view A, the note each of these capacities change both positively and negatively. Thus, frequency oscillation alternates both and above and below the resting frequency. The amount of the change is the determinant of the change of the capacity of the microphone. The change is called by the amplitude of the sound wave of the exciting with the microphone, the rate of which the change is frequency occurred is determined by the rate of which the capacity of the microphone changes. The rate of the change is called by the frequency of the sound wave. For example, suppose 1,000 hertz tone with a certain loudness strike with the microphone. The frequency of the carrier will then shift in a certain amount with say plus or minus 40 kilohertz. The carrier will be shifted 1,000 times per second. Now, assuming the loudness for the unchained, the frequency of the tone change with 4,000 hertz. The carrier with the frequency will shift the left with the minus 40 kilohertz, and then that will shift at the rate of 4,000 times per second. Likewise, assuming that the same loudness of the tone is reduced to 200 hertz, the carrier continues to shift left with the minus 40 kilohertz, now a rate of 200 times per second. This loudness to any of the modulation tones reduces one half of the frequency of the carrier will be shifted plus or minus 20 kilohertz. The carrier will be shifted at the same rate but there as before. Fills L requirements for the frequency modulation, but the frequency and the amplitude of the modulating signal are translated into variations in the frequency of the radio frequency carrier. 2.6 shows the oscillator circuit illustrating the frequency modulation. Microphone, capacitor, induction coil, tuning capacitor, ground, transistor, radio frequency, RFC, resistor, RFC. Your capacity decreasing in time and changing the instant of the sound wave change with the whisper normal voice. Normal voice is Y, loud voice is Z. Capacity of the microphone when idle. Capacity decrease and increase. X is whisper, Y is normal voice, Z is loud voice. Capacity of the microphone when idle. Frequency twice for that with the capacity change with the same amount but twice as often. Our figure 2.8 show how the frequency shift of the FM signal will go for the same variation over the modulation signal with the frequency dimension for the constant amplitude for the many of the remaining waveforms are present to be sure with the take of plane with the time of the server to adjust the figure for the tell you look at each one very over carefully and note everything you can see about everything noting everything you can about them. Doing this will help you understand that this material the maximum frequency deviation set with 75 kilohertz above the low with the carrier with the audio amplitude with the modulating wave must be adjusted to the beat at the driver to frequency with only between these limits. This can be referred to with 100% modulation. Although the term is remotely applicable to the FM projections along with the vertical axis to present the deviation frequency from the resting frequency carrier there in terms of the audio amplitude. The projection along with the horizontal axis represent the time the distance between A and B represent 1,000 for the second. This means that the carrier deviation resting frequency of the plus with the 75 kilohertz and thus minus 75 kilohertz finally with the back to the rest would occur with the 1,000 times per second. This would equate to an audio frequency of 1,000 hertz. For the carrier deviation period with A to B, the extent of the full audio limits of the plus and minus with the 75 kilohertz away with the fully modulated distance from the C to D is the same between from the A to B with the time interval frequency of the same as the before. Note that however the amplitude of the modulating wave the decrease for the carrier is driven only plus with the 75 kilohertz, only one half of the allowable deviation would be considerably only 50% modulation. If the system where A and F instead of between the E and F the interval introduced and reduced to 5 to 10 thousandths for the second indicates the increase of the frequency modulation signal of 2,000 hertz. The amplitude of the return to the maximum allowable value to indicate the deviation carried to the plus 175 kilohertz of the internal interval G and H represent the same frequency. The lower modulation amplitude is 66%. Note that the guard bands between the plus and the minus 75 kilohertz and plus and minus 100 hertz. Kilohertz. Therefore, this band isolates the modulation stream particular channel for the adjacent channels. Alright, percent of the modulation, and then we're going to cut the tape here, page 100.